Hello, welcome to today's lesson on linear systems of equations. So in Algebra 1, you solved some systems of equations, and they were called two-variable systems of equations. And so these probably look familiar here, and these two-variable systems, you had an x and a y, and you had to solve for x and y, and then your answer was written as an ordered pair in parentheses. So we're going to walk through. The first thing here is walk through and just show you what exactly you learned in Algebra 1, and then we're going to take it up a notch for Algebra 2. In Algebra 1, one of the methods that you use to solve systems of equations was called elimination. There was substitution, there was also graphing, but one of the ones that you learned was elimination. And what elimination is when you noticed that one of your variables could cancel out by simply just adding them together. You had a positive version and a negative version that when I combined them, it would be 0 and they would cancel out. That's called elimination. So we use elimination a lot in Algebra 2 forms of systems, and so that's why we're practicing this. So what we did was simply just find the variables that would cancel. They would add together here, and these would essentially just cancel out because positive y and negative y would be 0, y and be nothing. You add the rest, so 2x and x is 3x, and then 1 and 5 is 6. And then you just solve for x. So divide by 3. And now I get x equals 2. Now, I wasn't done there. That's just 1/2 of my answer. Because I also need to find out what y is, I can go back up here and plug in the x into either one of these equations. Now, I like to work with equations that don't have any negative signs. So the top one may seem a little bit more complicated, but it's not, and there's no negatives. So I'm going to plug this x equals 2 into the x right there. But you could plug it into the x in the second equation too. Either one works. And so when I do that, I get 2 times x, which we know now is 2, plus y, that's a y, equals 5. 2 times 2 is 4, so I have this. Subtract the 4, and I get y equals 1. Again, I'm not quite done. I did need to write my final answer as an ordered pair, x comma y. Your answer is always x comma y. So in this case, it would be 2 comma 1. And that is your final answer. And that was elimination. I mean, a pretty basic version of it of elimination, but it is an elimination problem. When we look at the second example here, though, sometimes when you did elimination problems, none of your variables canceled out. So when I look at this question here, I'll notice like if I combine these, neither one of them is going to cancel out. 2 and 4 don't cancel. 3 and 5 don't cancel. Over here, you had positive y, negative y. If I combine those, I get 0. But none of these, if I combine them, am I going to get 0? So what had to happen sometimes was you needed to, what I call forced elimination. You need to force the elimination to happen. So what we do in these cases is you look for, any multiples. Like, can I maybe multiply by something to then get them to cancel out? And hopefully you remember this, but you look here and you go, okay, well, wait a minute. I know that 4 is just simply 2 times 2. So if I multiply this by 2, I'll get 4. And 4 and negative 4 will cancel. And so what we can do is force eliminate by multiplying everything in that equation by that number. So 2 times 2, 2 times negative 3, and 2 times negative 7. So I'm going to go ahead and write this below. 2 times 2 is 4x. 2 times negative 3y is negative 6y. And 2 times negative 7 is negative 14. Now, when I go to combine these, now I get elimination. By simply just multiplying by something, I force the elimination here. And so now I can cancel these out. So my x's this time are going to cancel out, and then 5y and a negative 6y is negative 1y, and 13 and negative 14 is negative 1. Now I do need to get rid of that negative 1, so I'll divide, and y equals 1. Now again, not quite there, not quite done yet. I do need to find x, so I'm going to go back up here. I can plug in my y equals 1 into any of these three equations. I could plug it into this y for this equation. I could plug it into this y for this equation, or this y for this equation. I'm going to go ahead, since all of them seem to have minuses and everything, I'm just going to go ahead and plug it into the top one. So y is going to go into right here for y there. And so now I have 2x minus 3 times y, which we know is 1, equals negative 7. Now, negative 3 times 1 is negative 3. I add the 3 over, and you get 2x equals negative 4. Then when you divide, I get x equals negative 2. And so there we go. Negative 2 and 1. And remember, we write our answer in an ordered pair, x comma y. So it's negative 2, then 1. And there is our final answer. And so that was the way we did elimination when you were solving these problems. So we need to remember that, because essentially that's what we're going to be doing on a much larger scale when getting to 3 variable systems. In Algebra 2, we introduce a z. So no longer are you just finding x and y. You now have to find an x, a y, and a z. So there's 3 variables. And so your answer, instead of being an x and a y in parentheses, it'll be an x, y, and z in parentheses. So a 3 variable in parentheses there. So, and basically, because there are 3 variables, we have to then do elimination that many more times, because we can't just simply get one of our variables to cancel. So this is a 3 variable system. Notice you have x, y, and z. It's also 3 equations. If we simply get rid of one variable, then it doesn't really help us very much, because there's still 2 variables left. It's not like I could just take out the x and I can find y or z. I actually have to do this elimination multiple times. So we'll eliminate one of the variables, then do elimination again to eliminate one of the variables, then do elimination a 3rd time to finally get rid of another variable. That way, once we get down, you only have 1 variable left. So the same, you're looking for the same thing going on here. I'm trying to find things that would cancel out. Now, because you have 3 equations, you kind of want to look at all of them and think to yourself, well, this seems to be just, 2 times 1, and then this is just 2 times 2. So x's look okay to cancel out, because they're all multiples of each other, or all factors of each other. Whereas, it might be, harder to do, y or z. But actually, in this case, all of them seem to be pretty easy. But what we're going to do is first choose a variable that you would like to cancel out in part of our equation here. So I'm going to go ahead and cancel out the x's in these first 2. So I'm going to go ahead and choose those first 2 there. Now, what I have to look at here is if I'm going to get rid of the x's. These would need to be opposite in order for x's to cancel, and this is a positive 2. This is going to have to be a negative 2. That's the only way it cancels, is if you have a negative 2 and a positive 2. So to make that negative 2, I'm simply just going to multiply by negative 2. I do have to multiply everything in this problem by that, though. I can't just do one thing. Everything has to be multiplied. So what will happen now is now I have negative 2x. And then negative 2 times 2 is negative 4y. Negative 2 times negative 3 is positive 6z. And negative 2 times 11 is negative 22. And so what I'm going to look for here, what I'm going to look at now is this equation that's in the middle, and then the one I changed, which is down here now. So I'm going to look at both of those to do elimination. So now I can see that the 2x and the negative 2x will cancel, and I'm going to add everything else. 1y and negative 4y is negative 3y. Negative 2z here and positive 6z is 4z. And then 9 and negative 22 is negative 13. Now, notice how that doesn't really give us an answer here, because I still have two variables. I don't know what y or z is, so I can't find out what's what here. So what ends up having to happen is now I need to do this again. I need to repeat the process. So I'm going to get rid of all this clutter here. Oops, don't want to do that. Get rid of all this clutter here. And so now I don't even need this anymore, really. Now I need to look at the equations again. Now I did the first two already. In order to do this again, I have to choose a different set of variables. I can't do the same equations anymore. But so now when I look at these two here, I notice I can get rid of the x's again by simply just choosing the second and the third equation. We notice here that 4x is just simply 2 times 2x. So, and I do need them to be opposite. So if this is positive 4x, then this would need to be negative 4x. To get negative 4, I'd have to multiply by negative 2. So I'm going to multiply by negative 2, and I'm going to multiply everything by negative 2. And I'm going to get a new equation down here. Negative 2 times 2 is negative 4x. Negative 2 times y is negative 2y. Negative 2 times negative 2 is positive 4z. And then negative 2 times 9 is negative 18. And so now what I'm looking at this time now is this third one and the new one. So again, the x's are going to cancel. You have to cancel out the same variable you did in the first run. Otherwise it won't work. You got to make sure if you're going to cancel out the x's, that's what you cancel out. You can't switch. Adding straight down, 3y and negative 2y is 1y. Z and 4z is 5z. And then 16 and negative 18 is negative 2. Now I'm left with a two-variable system. So that whole process there of doing that twice was to get it down to a two-variable system. And now we can do essentially exactly what we did up here. So now that we're down to a two-variable system, we should already know how to solve this. Again, I have to look for another variable to cancel. We already canceled out the x's in two different equations, so that now we have just y's and z's. So now I'm going to repeat the process one more time to get rid of one more variable. It looks like the easiest one to do, this might get a little messy, but the easiest one to do here, since this is negative 3, this would just have to be positive 3. So I'm going to go ahead and simply just multiply this equation by 3. And so what that'll do is it'll make this positive 3y. 3 times 5 is 15z. And 3 times negative 2 is negative 6. So now, essentially, I have this one and this one to combine. The y's, negative 3y and positive 3y, will cancel. 4z and 5z is 19z. Negative 13 and negative 6 is negative 19. And so right here, this is where it's all downhill from here. I can see that if I divide by 19, I just simply get that z equals negative 1. Okay, so now we have to work our way backwards. Now that I have z, I'm going to do exactly what I did up here. You know, once you found one of your variables, you're going to go ahead and plug it back in to try to find the other one. So what I'm going to do is work my way up the line here, and I'm going to take my z and I'm going to plug it in one of these 2x2s. You want to make sure when you find your first answer, you plug it into one of the 2x2s, because if you try to plug it into one of the main ones, you're going to run into a problem, because by plugging in z, I still have two variables, and that's not going to work. Down here with the 2 by 2s, if I plug in for z, then all I have is y, and I can solve. So I can plug it in for either one of these. I think I'm probably going to do this last one here just because I can. So I'm going to plug this right here into the z right there. And so what that'll give me is 3y plus 15z, which is -1, and that equals -6. 15 times -1 is -15, equals -6. I'm going to add the 15 over. So 3y equals 9, and then finally divide by 3, and y equals 3. Almost done. Last step. Now that I have two variables, now that I have z and y, now I can take both of these and finally plug it into one of the big ones up here, because now I have two variables already and all I would need is x. So I'm going to go ahead and plug it in this last one. Let me clear all this up here, all this junk that's up here. I'm going to now put this y right in for there, into that y, and I'm going to take this z and I'm going to plug it in right there. And so let's do this one last time. I'm running out of colors here. So I have for x plus 3 times y, which we already know is 3, plus z, which is -1, equals 16. 3 times 3 is 9, and 9, so 9 plus -1 is 8, so I get 4x plus 8 equals 16. Subtract the 8, so -8, -8, I get 8. Divide by 4, finally x equals 2. And then that's it, I have all the variables. So my final answer will be an ordered triple, starting with x, 2, y, 3, and z, -1. There is my solution. And that's what you'll do for each one of these examples. If you want to rewind it and play it back, you can see how I go through each step. What we can do here is, again, when you get to these triple, I'm not going to solve this problem just because they take a long time, but you can just rewatch the first one I just did. But here, again, you want to make sure you do these in multiples. This is 1, 2, 3, so that would probably be an easy one to do. This one's a little bit more difficult because 3 and 5, you have to go to like 15 or something. Here with 1, 2, and 6 might not be too bad, but it looks like the x's, again, are going to be the easiest thing to get rid of because I can just simply make this -2, and then it cancels with this equation. Or I can make this -3, and it'll cancel with the bottom equation, and then I add straight down. Remember that you do elimination twice with two different sets of equations and getting rid of the same variable. That way you're left with a 2 by 2. Then once you have a 2 by 2, you'll do elimination a third time to get rid of the second variable. And then you'll be left with 1, which you can solve, and then slowly plug them back in to find the answer. Again, if you want to rewatch the process, rewatch this and how I got these 3 pieces of the answer, that is systems of equations. In the next video, I'm going to show you how you can check your answer using your graphing calculator. And also, as an incentive, once you show that you can do this algebraically, like showing all your work here, showing all your math, once you can do this algebraically, you will be able to use the calculator to find the answer for these after you've mastered this algebraically, which will make your life a lot easier. So, all right, see you in the next video.